and let it go at that. So we're going to talk about generators, a little bit about some of the principles and fundamentals of how they make electricity, get into some applications, talk a little bit about some of the code requirements, some different classes of generators. Then we're going to look at some transfer switch issues and try to clear up a little bit of a muddy, confusing area, and then wrap up with just a quick look at what might be coming in the future in the way of solar or windmills or some fuel cells or some of those kind of technologies. And that'll wrap us up. So, like I said, it's your session. If you got any questions, comments, feel free to jump right in and we'll talk about it. We're hosted and sponsored by the university, and I appreciate all of the help they've given us over the years, and glad to be here. We just talked a little bit about this, an outline of what we're going to cover tonight. And we'll start with talking about the most important scientific discovery of all time. And we're not talking about Viagra. Back in the day, excuse me. I was supposed to mash that button before I got this far along. Back in the day, Michael Faraday somehow was playing around and discovered that if you take a conductor with a closed circuit and move it through a magnetic field, current will flow. And that has led us to the industry where we are today. If you don't have electricity for a period of time, and not a very long period of time, it's a life-threatening emergency. I mean, it's gotten to the point now where electric power is almost a demand. It's a necessity. It's something we just absolutely can't do without. And I mean, after all, if you don't have electricity, you can't even operate your computer or your little screens or all the little electronic crap stuff that you have to operate and everybody depends on anymore. So it's gotten to be a real big deal. But it all started with this, where you create a magnetic current, a current when you spin a wire through a magnetic field, and this is what happens. You notice that when we start moving this coil of wire, we're at this position on the sine wave. There's nothing going on. And that's because at this point, we're moving parallel with the magnetic field. We're not cutting any magnetic field force lines. So there's nothing happening. But as we rotate through 90 degrees, we will start to build an increase in the pressure or the voltage on our circuit. And it peaks at 90 degrees because here we're cutting the maximum number of magnetic force field lines. And as we continue to rotate, we're back at the position here, right here, where there's no field force lines being cut, so there's no voltage, no current flowing. Everything is back to zero. And as we continue to rotate to this position, we hit a maximum negative value on the sine wave, because now we're going back, instead of being on the south pole, we're back to the north pole, so we're at the opposite end of the sine wave. And then we continue back to the same point as we were here, and we're back to the zero origin, and the whole cycle repeats again and again to create a sine wave on an AC current. So what about DC? What if we don't want an AC? Well, what we do with the DC is we take and split the rings. Instead of having two separate rings for the conductors at the end of our little loop of wire, now we put one on each of these so that as it rotates, every 90 degrees, every 180 degrees, we switch polarity. So what was negative now is positive, and we just continue to rotate so that instead of having a sine wave, we wind up with a little lumpy DC waveform like this. And it has essentially the same thing going on here in the loop passing through the field is there's nothing here to create a current. We start at zero, there's nothing there. And it peaks as it rotates past the 90-degree point on the south pole, and that's point B at the peak. And it rotates back 180 degrees, and at that point, we switch with the commutator to the other polarity. So now as it continues to rotate, we create another positive point on the sine wave instead of a negative. And that would be a pretty lumpy, chumpy thing to have to deal with. So what we do, instead of just having two of them, we make a whole bunch of them. And the commutator, each one of these represents one of the windings on the DC generator. So that as it rotates, instead of having the little, two little lumpy things, now we get a whole bunch of them that fill in together so that there's just a little, what they call ripple on top of the sine